Hello everyone, Namaste and welcome back to JCE Connect. I am Naresh V. Patil and today I am here to discuss the next part of design of pre-stress concrete structure, and today I will be discussing about the flexural strength of pre-stress concrete section. The flexural strength of pre-stress concrete structure or section. Okay, so first, before proceeding to the part, so we'll discuss first what is flexural strength. What do you mean by flexural strength of section? What is flexural strength of the section? So the flexural strength of the section is nothing but the bending strength of the section or a bending capacity of the beam, which is developed by the internal resistance of the section or the internal resistance of the material. Okay, so I'll repeat once again. The flexural strength is nothing but its bending strength. The flexural strength of the section is nothing but the bending strength of the section, which is developed by, the bending strength is developed by the internal material provided in the section, or it is nothing but the internal resistance of the section. So internal resistance is very important for design of flexural member. Okay, the internal resistance is very important for the design of flexural member. Okay, so we'll discuss about the flexural strength first. Okay, so we can see here there is one beam, okay, simply supported of rectangular cross section loaded with W. So when this beam subjected to external load W, it will transform into bending. Okay, so when a member subjected to external load, it will bend. Okay, it has to bend. So after that, so when the bending takes place in the section, the behavior of the member will differ with respect to its neutral axis. The behavior of the member will differ with respect to the neutral axis of the section. So here what will happen about this neutral axis? Okay, when the bending takes place downward side, or sagging bending we can say, or sagging bending. So with respect to the neutral axis, the fibers above the neutral axis subjected to compression, means these fibers above the neutral axis subjected to compression, and the fibers below the neutral axis subjected to tension. The fibers or the material below the neutral axis subjected to tension, and whatever the compression or the tension developed in the section because of the external load, whatever the tension and compression developed in the section because of the external load, that has to be resisted by internal resistance, the internal resistance of the material, developed by material provided in the section. So that is nothing but its flexural strength. So we'll move ahead again. So you can see here, okay, we'll take up a section, means for this member it is a rectangular section for B, width B and effective depth D. Okay, and when a member subjected to bending, I told you subjected to bending about the neutral axis, the fibers above neutral axis will be under compression, and the fibers below the neutral axis will be under tension. Okay, the fibers below the neutral axis will be under tension, and ultimately whatever the external movement or the external bending moment or the bending of the beam will be resisted by the internal resistance, means compression and tension will be resisted by these two forces. Means whatever the bending moment occurs, for example, the bending moment M due to external load, that should be resisted by these two forces. How the means these two are nothing but the internal resistance of the member. These two forces are the internal resistance of the member. Okay, means how they will develop a moment here now. This is external bending moment. That should be resisted by the internal movement or the internal resistance of these two forces. The internal resistance or the internal bending moment of these two forces. And how these two forces will overtake the external bending moment or resist the external bending moment. So what will happen? The C or T will act to each other with a force Z, or we call it as a lever arm. Means what will happen? Either C will act about T and it will form a couple, or T will act about C and that will form a couple. So what will happen? Force into perpendicular distance, nothing but movement. Again force into perpendicular distance, nothing but a movement. So that is whatever the force, the tension will act about compression, or the compression will act about tension. These two forces will develop a internal movement of resistance. So that is also only it is called as this movement will be resisted by internal movement of resistance. This is called as internal movement of resistance. What is the internal movement of resistance? See, the word is very important. Internal movement of resistance. So that should be more than our external bending moment. Means the compression offered by concrete and the tension offered by steel in this section. क्या होगा अभी यहाँ पे? Compression develop होगा, कौन लेगा? It will take care by concrete, and whatever tension is developed that will be take care by steel. And these two forces will act each other. These two forces will act over each other about the lever arm Z, and these two forces will develop one movement. That movement is called as the resistance movement or movement of resistance. And if this movement of resistance, which is nothing but the T will act about C or C will act about T, okay, if that internal movement of resistance is less than, if this internal movement of resistance is less than the external movement, then your section will fail. Means what? The internal resistance developed by the material or the material provided in this section is not capable to bear the external movement. Is not capable to bear the external movement. So that is nothing but the internal resistance, or it is also called as the flexural strength, or flexural strength is nothing but the bending strength. When the beam bends, what will happen? The fibers above neutral axis subjected to compression and the fibers below neutral axis subjected to tension, and the compression will be offered by concrete, the tension will be offered by steel, and these two forces C and T, C offered by concrete, T offered by steel, act over each other about lever arm Z, and they will develop the internal movement that is also called as the moment of resistance, and this moment of resistance should be more than factored bending moment acting on the beam. The internal resistance developed by the section should be more than factored movement or the factored bending moment acting on the beam. Then your section will be safe, or your section will not fail. Okay, your section is safe. So that is itself, it is called as flexural strength, nothing but bending strength. Now we'll talk about failure. Okay, just now we discuss about how the section will fail. We have to take care how the section will fail. Okay, so we'll discuss about that also in today's lecture. Okay, so there are three types of flexural failure in pre-stressed concrete sections. There are three types of flexural failure in pre-stressed concrete. That is, first one is fracture of steel in tension. Fracture of steel in tension. Second failure is failure of under reinforced section. Failure of under reinforced section. Third one is failure of over reinforced section. So we'll discuss one by one. So first we'll discuss about the fracture of steel in tension. Fracture of steel in tension. We'll discuss one by one. So that is, first one is fracture of steel in tension. Fracture of steel in tension. Okay. So what will happen? What do you mean by fracture of steel in tension now? So here what will happen? Due to fracture of steel in the tension zone, due to fracture of steel in the tension zone, how it will happen? So generally when a member subjected to bending, a member it has to bend like this. Okay, and to resist that bending, we used to provide the reinforcement at the tension side. So this is the tension side. So this is our reinforcement. Okay, or steel. Okay. So generally in pre-stress member, the sudden failure will occur, means it will be without any warning, generally due to fracture of steel in tension. तो क्या होता है? Whatever the steel provided in the tension zone, so in pre-stressed concrete member, generally the failure will take place suddenly without giving any warning because of failure of tension steel provided in the section. This type of failure is imminent when the percentage of steel provided in the section is low than the minimum steel required in the section. Okay, so in this case, so whatever steel is provided in the section, if that steel is less than minimum, the percentage of minimum steel or the percentage of steel minimum required to be provided in the section, if less than that, what will happen? The section will fail because of fracture of steel in tension. So whatever steel we provided in the tension zone, if that steel is less than minimum percentage of steel as per the code, then what will happen? The section will fail without giving any warning, or it will fail very suddenly. Because of what? Fracture of steel. Understood? So what will happen here? When you provide steel which is less than the minimum percentage of steel, what will happen? Automatically whatever the stresses are there, it will transfer to steel, and the steel is less than the minimum steel provided in the as per the code. So the steel will fail, and it will fail. How it will fail? It will fail like it will not give any warning. It will fail suddenly. So I'll repeat once again. If the steel prodded in this section is low, that when the concrete in the tension zone cracks, the steel is not in a position to bear up the additional tensile stresses transferred. Understood? So whatever the steel is provided, if that steel is less than the minimum steel as per the code, so whatever the additional stresses are going to transferred, for that it is not capable, or that steel will not bear the additional stresses which are going to transfer. So that time the section has to fail. The section has to fail due to fracture of steel in tension. Due to fracture of steel in tension. So that is nothing but it is called as fracture of steel in tension. So I'll repeat once again. When the steel provided in the section in the tension zone, if the quantity of steel provided is less than the minimum steel as per IS code, so whatever the stresses are going to transferred over this section, or this steel will not capable, it will take the stresses, but it will not take the additional stress, means it is not up to the factor of safety, because we are provided steel less than minimum percentage of steel. Okay, so that steel is not bare or not capable to take the additional stresses which is going to develop, or which are going to develop in the member. So that member has to fail because of fracture of steel in tension. Okay, understood? So that is regarding first failure. Now second failure is failure of under a reinforced section. Failure of under reinforced section. Okay, so it is under reinforced section means the cross section is provided with an amount of steel greater than minimum steel. Okay, तो इस केस में क्या हो रहा है, we have provided the reinforcement. In this case we have provided the reinforcement more than the minimum steel. Okay, understood? But still the failure will takes place. How? So here what will happen? Here what will happen if I draw the sketch again? Here the neutral axis will shift. So your stress distribution diagram will become like this. Your neutral axis will shift. So here it is nothing but the stresses in steel. So because this is subject to tension, this stresses in steel. So this is a steel provided which is more than the minimum requirement. Okay, which is more than the minimum requirement. So what will happen here? Because of this, the stresses, whatever the additional stresses developed in the case 1 or the first failure are going to bear, because we are going to provide the additional reinforcement, or the reinforcement which will be more than the minimum reinforcement. So automatically what will happen? Whatever the tension is going to develop is to be bear by the steel, or the tension will be offered by the steel, and the elongation will takes place. The elongation of bar will takes place. So during elongation what will happen? The steel will reach its ultimate value. But concrete is not reached its ultimate value. Steel has reached its ultimate value. and because of that what will happen, the crushing of concrete will takes place in the compression zone, or the cracks will propagate in the compression zone, because concrete is still strong, because concrete has not reached the ultimate value but still has reached the ultimate value. The steel which is provided in the tension zone has reached because it has taken care the additional stresses developed in case 1. केस 1 में फेल्योर क्यों हो रहा था? बिकॉज दैट स्टील इज नॉट रेडी टू बेयर द एडिशनल स्ट्रेसेस डेवलप्ड इन द सेक्शन. So in this case what we did, we have provided the steel extra or the steel which is more than the minimum steel. So what will happen, the stresses in the material or the steel will reach its ultimate value and the failure will take place because of crushing of concrete. Understood? So next failure is called as over reinforced section. Next is third one is over reinforced section. Okay, so in over reinforced section what will happen, the percentage of steel PT, the percentage of steel, you can say PT, will be more than PT limit. The percentage of steel will be more than PT limit. Means इस केस में क्या होता है, we are providing huge amount of steel in case of over reinforced section. We are providing huge amount of steel in case of over reinforced section. So what will happen here, if I draw and if I explain once again about the sketch. So the behavior will changes like this, like this. So here in this case the stresses will reach the ultimate value. Stresses in compression zone, because we are provided the huge amount of steel, the percentage of steel is more, though what will happen here, the steel will not reach its ultimate value. The steel will not reach its ultimate value. But what will happen, the steel is capable to bear the additional stresses, or is the steel is ready to elongate for longer duration. But because of that will happen, the steel is ready to elongate, but what will happen in concrete, concrete is crushing simultaneously, concrete is crushing simultaneously. So that time what will happen, the concrete will fail immediately because of crushing, because we are provided steel more than the PT required or more than PT limit. So because of this what will happen, the steel is behave or it will take tension, but still it has not reached the ultimate value, or still it has not reached the tensile stress or the maximum tensile stress. Understood? Steel has not reached the maximum tensile stresses, but simultaneously concrete is undergoing compression, or the concrete will crush. The concrete will crush, and that time there is a possibility sudden failure will occur due to crushing of concrete, So this failure is also called as compression failure. This failure is also called as compression failure, because here the material or the failure of the section is taken place not because of tension or the steel reached the ultimate stress, but concrete has reached the ultimate stress. So that's why it is called as compression failure. So this is regarding the about what is flexural strength and how the flexural strength developed in the section based on the internal resistance of concrete and steel, and beyond that how the failure will take place because of the some factors or some activity taken place in the section. That is because of percentage of steel or because of the stresses develop in the steel and the concrete both. Because of that, how the failure will take place. Okay, so this is regarding the today's session. Okay, and if you get any queries in this, or if you want more discussion over this, you can call me back. Okay, thank you.